Hi, welcome to Solving Science Part 2. We have a massive problem with the early universe. The James Webb Space Telescope is observing supermassive structure, star formation, galaxy formation much earlier than our cosmological standard model, ΛCDM, is predicting. We're seeing highly developed galaxy formation much earlier. Now, it's reported across the media, you can see it, but I've picked out a report from the Astrobites website, and I'll read from the report from that website. Recent observations from the James Webb Space Telescope have thrown a curveball at our standard cosmological model, the lambda cold dark matter model. It's reporting the existence of early massive galaxies with stellar masses way larger than the model predicts. According to ΛCDM, the first structures to form in this scenario should typically be smaller ones. Recent observations by the James Webb Space Telescope have unveiled the existence of ultramassive galaxies with a redshift of 7 to 10, with stellar masses that surpass the expectations set by our standard model. Now, this is a problem. How are these structures forming so early in the universe? NASA here in a paper are asking, how can nature make such bright, massive, large galaxies in less than 300 million years since the Big Bang, which is a snapshot in time? Galaxies are far more numerous and brighter, and they are a significant order of magnitude difference between what we observe and what our standard model predicts. So, these are not the types of galaxies we expect to see in this space, and there is an abundance of early bright galaxies much higher than the theories predict. So the question now is, what can expanse tension theory offer to this problem? Is there anything that expanse tension theory can propose? Yes, there is. So there's two things. Firstly, we're in a lower density, we've got a contrast between low density space because of expansion, but high density space where you have the collapse of matter into galaxy star formation, for example. So we've got two scenarios where expanse tension theory can offer. Firstly, it can reduce the expansion opposition inside those overdensities, helping star formation efficiency, which would be boosted, and my calculations suggest star formation efficiency could be boosted by between 50 and 80%, which aligns with the amount of star formation and galaxy formation that we see. We also then see expanse tension theory supplies a physical driver for the elevated efficiencies. It would also give us a shorter effective collapse time of matter in its contrast to the low density void. Remember, expanse tension theory is a gradient between low density space of the void and high density of matter, star formation and galaxy formation. So they're the two scenarios we get. The modelling that I've currently done suggests the volume of these galaxies we're seeing in this very early universe could emerge out of an expanse tension theory universe. So potentially offering a different perspective, a different theoretical model of how this early universe star formation, galaxy formation could come about. Clearly we have a problem with ΛCDM. Our standard cosmological model isn't working. These papers are saying scientists are now re-evaluating the model again. Now remember, ΛCDM already includes 26% dark matter, as in a mathematical cheat to say there's some matter there we can't see. It already includes 70% dark energy. Again, a mathematical cheat to say there's 70% energy somewhere that we can't detect. So we've got a 96% mathematical cheat in the formula before we even start. Expanse tension theory, it doesn't have any of those things. It's a causal mechanism based on the attraction, the coupling of the expansion field of the universe and the coupling to matter depending on the density of space. But that low to high density difference could be driving the change that we're seeing in this early universe. So, another potential win for expanse tension theory in a fairly substantial problem of the universe. Okay, thank you for watching. Thank you for subscribing. Please share the channel with anybody that you think might be interested in an understanding of science. Okay, bye-bye.